Okay, today is the first day of probability. Day one of probability. What is probability? In your own words, if you were explaining it to like a second grader, if you were like doing backpack tutoring or something, what's probability? Yes. Chance something's going to happen. Good. Now that doesn't have any definition of like how you find it, but it is generally the chances that something's going to happen. Okay, would you say the chances are high that somebody in this room is going to eat white bread today?
I already did.
Raise your hand if you already have. Oh wow, that's already 5 people already have. Okay, so that's a pretty high probability event. Okay, what is the probability that somebody is going to eat white rice today? Well, you'd have to actually do a little statistical survey and like do an experiment, and you can find out actually what's the probability. All right. So in other words, I could have you write down like yesterday whether any of you had white bread, for example, my example before. And then we could see, okay, looks like 3/4 of the kids had white bread sometime during the day yesterday, so we can assume it's probably going to be similar the next day. Is that perfect? No, because what if yesterday was like white bread day? You know, that could obviously change things. Or today is like Chinese food day, and so like like in the cafeteria they're going to have a big Chinese thing, and like we were on a field trip and you only were exposed to Chinese food. You can change these things, but that's the whole point of randomness. Another thing that's important in probability is it's got to be random. You can't have a weighted die. There is such a thing as a weighted die. You know what you use them for? Cheating. That's right. And if you have a weighted die, it will come up a certain number. Now, usually the people that weight dice are doing it to have the number 7 or the number 11 come up on the dice, because there's a certain game in Las Vegas where all you do is roll dice for the game. And if you can get a 7 to come up on your first roll or an 11 to come up on your first roll, you automatically win whatever you had bet. So if you had bet $1 million, you roll a 7 and you will win $1 million. So you can see how powerful it would be if you could have weighted dice. Well, of course, they're really careful about the dice. They change the dice out all the time. So if somebody did sneak weighted dice in there, they would be able to get it off the table because they're constantly changing them for new dice, and they're really careful about it. They have cameras, of course, to watch for people that, if you ever take the dice off the table, they're going to say, oh, we got to put in new dice because you took the dice off the table, and you might have done something sneaky like drop them in your pocket and then take them back out again with different dice. Anyway, probability is something that is super complicated at the end. And so we need to keep coming back to some certain definitions and things to help you understand it. So I think by the end you will understand probability better than you ever have. This class right here, Honors Higher Algebra, teaches the most probability of any class in this entire high school. And compared to most college classes, this teaches way more probability than most college classes too. So this is the heavy duty, like you will totally understand probability by the end. You'll even understand really complicated ones. All right, but it all comes down to what you want over what's possible. That is not an official math definition. I try to make sure you understand this in like real world terms. What you want over what's possible. And I always encourage people to start with what's possible. And you figure out all the possible things that could happen, and then you can figure out the top part. It's some subset of the bottom. If I say all the things that are possible are, you could roll a 1, a 2, a 3, a 4, a 5, or a 6, and then what you want is to roll a 2, then it would be 1 thing on the top and 6 things on the bottom, and then it's just 1 over 6. Think about it, heads and tails. What's possible if you flip a coin? Heads or tails? And what do you want? Well, it depends. Tails never fails, of course, so I'll put T on top. Okay, and then what is that in terms of numbers? There's 1 of these and 2 of those. That's why it's a 1 out of 2. Another thing we got to get you understanding is that if you say odds, that is different than probability. Odds are different. Okay, the odds I'm going to win. People use that for probability all the time. It's not probability. It's related. It's not the same thing. Okay, so the official math definition is favorable outcomes. Outcomes means things that happen. Favorable outcomes divided by possible outcomes. again, for a die, you roll a die, how many things can come up? 6. I think 6 on a die. 6 things can come up. Okay, and then, oh, 1 or 2 dice. I gotcha. Yeah, I'm talking about 1 die right now. A single number cube. Some people think die is too, like, sounds too scary, so they won't maybe use number cube. But anyway, so 6 things, raise your hand, please. 6 things are possible, and then favorable outcomes are which ones do you want to come up? I want to do a demo here right away and just see how many of you guys guessed this correctly. All right? Obviously, there's a 1 in 6 chance that you're going to win this on rolling the die. I want you to get the difference between probability and odds right away. The odds that we're going to get, okay, pick a number. 3. Okay, you just pick 3. The odds are, for him, there's 1, 3, and there are 5 other things. The odds are 1 to 5 that he's going to be right. But the probability is all the things that are possible, and then what you want on top of that. There's only 1 thing out of 6. Do you get how that's different? The odds are 1 to 5. 1 thing wins, 5 things lose. The probability is 1 in 6. Get that straight in your head. These are odds. This is probability. We are doing probability. They're related, but different. Okay, now I'm going to roll the die, and it is a 4. So you didn't win. You probably knew that was going to happen, right? All right, but if you get enough people to guess, I get my probability goes up a lot that somebody's going to win. All right, so everybody guess a number between 1 and 6. Write it down on your iPad. I want you to show your number to somebody else. Anybody else? Okay. All right. Now, I also want you to guess a coin flip. Heads or tails. So put an H or a T. I'm not going to show you, of course, but all right. It's either going to be heads or tails. So you might have said, for instance, 5 and tails. Okay. Or you might have said 4 and heads. All right, so you have both things on your iPad. I am going to predict the probability that one of you wins. I'm going to predict, I shouldn't say it that way, the probability that of how many people would I expect to win right now. I would expect 3 of you will win this little game.
Perfectly.
You'd think, yeah, get the heads and the 7 or whatever it is. It can't be a 7. There's only 6 numbers. Okay, like heads and 6 or whatever. There's going to be, I'm going to guess 3 people. Maybe 2, but I'm going to guess 3. How many people are in the class? Good question. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 25, plus, if you include me, 26. Okay? Oh, I didn't guess, so we should probably not include me. So 25 people. And I'm guessing. See, last hour, it seems like we always have 1 more than I would expect. I kind of expected 2 people to win, but 3 people won. That also is an experiment. It helps me to tell whether you're going to, what probability is that you're going to win. No, not going to happen. Okay, so here we go. It's a 6 and a tails. How many people won? Raise your hand if you won. 3 people won. I predicted that. Ha. Now, do you get that companies have to actually do this kind of thing all the time? They have to be able to predict how many people are going to win their game. Because, like, if you were playing this game and the company, your boss comes to you and says, okay, here's my plan. I'm going to have people pay $1 to play the game. And then if they win, we're going to pay out $20. And let's say that you're the person in charge of the finances of the company. Keep it really simple. Hopefully you would say that's a really bad plan. Because your probability of winning is too high. Let's do the probability of winning this game. Well, what's the probability of the coin flip being right? 1 and 2. And what's the probability of the die being right? 1 and 6. You multiply them. You almost always multiply probabilities together. These are like those little rules you can come back to, and you're like, okay, I get this probability, I get that probability. What do I do with them? You almost always, that's not the word always, but almost always multiply them together. In this situation, you would always multiply them together, and you get 1 in 12. There's a 1 in 12 chance of you winning. So therefore, if there's 24 people in here, do you get why I guessed there'd probably be 2 or maybe 3 people would win? All right. Technically, there's only supposed to be 2 winners, because there was, if you think about it, if you double the 1 in 12, if we had 24 people, that would be the perfect number to test with. With 24 people, we should have had 2 people win. All right. So one thing at a time. If you do 2 probabilities together like this, what's the probability you're going to be bit by a dog today? It's probably only a 1 in 10,000 chance of that, right? How many of you have been bit by a dog at some point in your life? All right, I have. All right, and is there a chance that you could be bit by a dog and by struck by lightning in the same day? Yes.
How big is it?
The probability, infinitesimal. Okay, so it would be, let's say, a 1 in 10,000 chance of being bit by a dog, and then a 1 in, let's say, 10 million chance of being hit by lightning. People do get hit by lightning. It happens all the time. It happens a lot more often in certain places, like on golf courses and stuff. So now, if you happen to be doing this probability with a guy who adopts abused dogs, who's walking his 12 dogs at the same time across a golf course in the rain while holding up a golf club, now your probabilities have changed. Much increased chance that you're going to be bit by a dog and struck by lightning. Okay, so you can see, obviously, that wouldn't be a random situation, right? All right. So we need randomness to make this work. Otherwise, you can make things pretty much for sure going to happen. Okay, like if I want to stack the deck. All right. So it's what you want over what's possible. It's favorable over possible outcomes. Now let's actually do some charts. This one is not something you're going to be able to read real well on the questions, but at least you can see the big chart. You are either a female or a male person, and I know that I know, isn't there a other category? Actually, in Minnesota, I believe they've just passed a law, something to the effect of that you are, if you are transgendered, that you get to choose which your identity is. But I don't think there is an other category.
They're trying to
Okay.
put a name for like
By
species and
Yep.
gender, by definition, there are 2. Male and female. Look it up in the dictionary.
All right. So you get to choose the female-male thing. I will not argue with you. And then, well, medium, and rare are your choices on your steak, or in this case, hamburger, I guess. Do you get the difference? A lot of people don't. Well done means it's cooked a lot, and it's like there's no pink at all. It is like pretty much gray on the inside because it's been cooked thoroughly. Okay. Medium is obviously it's kind of a range. Medium means it's not cooked as much. It's cooked kind of in the middle. It's got some pink in the middle. And rare means that it's not been cooked. It's rarely cooked. It's cooked a little bit on the outside, and it's very moist and juicy on the inside. Lots of pink. Okay? And it all depends on you and your own personal choices here. How many of you are a female person who would like their hamburger well done? Raise your hand if that's you. I'm going to be polling the whole class now. Only one person for well done. Last hour was lots of people. All right, how about medium? Female person, medium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I know there's always in-betweens, but we have to pick from these 3 choices. Okay, female person, rare. Female, rare. 1. I like the rare 2. Male person, well done. Male person, well. That was the same last hour. Interesting correlation there. No guys picked well done last hour. Although last hour we had lots more females picking it. But all right. And how about male would choose medium? 1, 2, 3, 4, 5, 6, 7, 8. And male person that would pick rare. 1, 2, 3. All right. And I won't include myself so we can keep our totals at 25. And then the totals. So I actually add them up. 11 plus 1 makes 13. And then I'm adding these up, 8, 9, 10, 11. And then I actually add up the totals for everything. 1 plus 0 is 1 plus 0 is not 0. It's 1. 19, 4, add 24. Okay. So now, what's the probability if I told you right now that I was going to pick like randomly off the seating chart, just like pick a number, that I would get a kid who likes it rare? Write a fraction for me. It's something over something. It's what I want, which is the people that would be rare lovers, out of what's possible, which that's one of the hardest things to figure out is the bottom. Would you agree that there are 4 people who like rare? So I'd say 4 out of how many were possible? 24. Could you reduce that? 1 out of 6. That's what I was looking for there. Raise your hand if you would have known that one. Okay, good. Now, I'm going to change the problem. And, of course, that kind is super easy. Here's the kind that's harder. Given that I'm only picking, I'm making this really easy by how I'm wording it, but given I'm only picking from people who like medium, because I got this hamburger and it's already done and it's a medium, okay? I'm only picking from people who like mediums. What's the probability that I will randomly pick a guy? A male who likes mediums. Now remember, I said given I'm only picking from people who like medium. Do you get the whole rest of the chart disappears and that's all I'm picking from? Those are the only numbers you can use then. Okay, so then if it's a guy, it must be the 8 out of the bigger number. The total is 19. Raise your hand if you had 8 out of 19. Okay, good. Now I said that one really obviously to try to narrow it down to just the people with medium, but here's a way to say it a little more subtly. What's the probability that a randomly chosen female would want medium? A randomly chosen female would want medium. You got to figure out what it's out of. The bottom number. Turn it my way and I'll tell you if you're doing it right. Yep, 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 yep. Yep, 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 yep. Bottom number's wrong. Yep, 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 yep. Can't see the bottom number. Can you zoom in a little bit more? There we go. Got it now. Yes, that's right. And yes, and yes. Okay, good. And yes. So it was 11 out of 13. The important number there, I said randomly chosen female. Your eyes should have gone like this, narrowing in on just this part. Can only use those numbers. As soon as I said randomly chosen female, I know some of you think randomly means anybody's possible, but as soon as I say randomly chosen female, go. Then I have to narrow it down to just this. All right. So now, how about given I'm choosing only from people who love rare hamburgers, because I've got a rare one and I got to give it away now. What's the probability I'm going to pick? Who is one of the ones that liked rare? What's the probability I pick Noah? Yes, 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 yes. Yep, 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 yep. That's odds. I need probability. Total goes on the bottom. Yep, 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 yep. Okay, there's 4 people to pick from. And the probability I was going to pick Noah then is 1 out of those 4, because he's 1 of those 4. All right. Good. I think you get the idea. Now let's talk about ands and ors. Okay, let's say that I toss this coin out there. And I'll use a paper clip so it won't be like super popular. And I say the person I toss this to, all right, it's going to end up on the floor somewhere. All right, now, so that paper clip, did it actually go perfectly in a backpack? Oh my gosh, that's bizarre. All right, so Okay, that's fine. It's yours. Lucky you. Okay, so if I toss that clearly to a random person, then what's the probability? Watch my probability go up here. What's my probability that this person loves dogs, or loves cats, or loves horses, or eats bread, or likes cereal? Okay, the point is, do you get that as I said, or it increased my chances over and over and over and over again? Because maybe she doesn't like dogs, but she must like one of those things. Okay, so when I say, please tell me at least one of those. Was at least one of those right? Okay, good. So then, as soon as you say or, you are getting a bigger number, you are adding on the top. Try to remember that. If you do or, that's adding on the top. So, if I'm talking in context of this hamburger question about this, I'm going to say, let's say that I randomly pick a person. What's the probability I'm going to get somebody who likes medium or rare? Well, I'm randomly picking a person. As soon as I say something generic like person, that means anybody's possible. Always get that straight first. Then, what did I want? I wanted somebody who liked medium or rare. 19 plus 4. So the total there is 23 out of 24 chance of that then. Okay. So let's do another one like that. Or, what if given that I'm only picking from the males, what's the probability that I'm going to find somebody who likes well or medium? And everybody that's showing me is getting it right. 8 out of 11. Very good. Now I'm going to change it. Medium. No, I'm going to go. Given we have people. No, I can't do it that way. I got to go with females now. Given that I'm choosing only from females, what's the probability that they're going to like rare or well? Got 2 numbers up there, but yes, 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 yes. Everybody's getting it right again. 2 out of 13. Okay, I think you get the idea that or means add. How about if it's neither? I'm picking only from females now. You should do that when you're doing the problems. If I'm only picking from females, given it's a female, then what's the probability that the person will like neither medium nor rare? So when I say neither and nor, I'm crossing them out. Can't be that, can't be that. What does that leave me with? Pretty much that 1. So it's 1 out of 13. It's you. Okay, good. All right, moving on. I think you got the idea. Let's get to your homework. Everybody find your homework. It looks like this. It's called probability tables. You're right, going to. All right. While you get your homework up, you remember I tossed the paperclip to a random person? Watch my probability go down as I do this. What's the probability that the person liked white bread and has a parent with a car and who has been to California and has got a liger living in their basement? A lion-tiger cross.
Well, your probability.
Do you? Yes, at the end there it went way down. My point, as soon as I say and, my probability is getting smaller and smaller and smaller. As opposed to when I say or, it gets bigger and bigger and bigger. Does that make sense to you? If I say this has to be this and this, then my probability just went down. Less people. If you get the idea that or answers are bigger answers and answers, which seem like it's this and this, and so you're adding, it's not. It's counterintuitive. If I say this and this, my probability actually goes down. because you've got to pass both tests. You've got to be both a dog lover and a car owner, and that probability goes down, down, down. So and answers are small, or answers are big. Okay, good.
Are we having 3 tests of some probability?
There will be 3 parts to this test. Just be happy it's not all in one big test. That would be really nasty. Yeah, it's split up in 3 parts. And yes, in case I didn't say this before, in normal higher algebra, they take, at least last year, they took an entire quarter to do probability. The whole quarter was probability. We don't do it that long, but we do it for like 3 or 4 weeks, as opposed to, like 6 or 8 weeks. Okay, so anyway, there's a lot of probability, and we're just scratching the surface here. Okay, so I hope each day it's just a little bit harder, and I hope by the end you're going to feel like I can handle any tricky problem you throw at me, because we're going to spend a lot of time, and you'll get better and better each day. All right, so this chart, let's start with A. Find the probability a randomly chosen person is a man. As soon as they say randomly chosen person, that's kind of like our code word for it could have been anyone, which means you look for the total, total. And that's all the total people. The biggest number you can find is what's possible, 3172. But then what we want is that this person would be a man. So therefore I got to find the total of all the men. And there it is. So it's 1570 over 3172. Now I know it says in the directions that you are supposed to divide and get a decimal. I'm going to save you time on this assignment, and I'm not going to ask you to get the decimal. Do you get that all you do is take the top number divided by the bottom number? That's it. That's to change it into a decimal. That's all you do. Now, I just don't want to have you do that on every single problem, because it seems dumb to me to waste the time doing that. We'll do that for the tests, and you'll have a calculator for the test to do it with. Do you agree that leaving it as a fraction is a reasonable option? All right, good. Yes. I don't need you to simplify them unless they're obvious. Like, in other words, I have no clue if 1570 over 3172 reduces, and I gotcha. And I don't need you to reduce the fraction. Again, I'm trying to get across big general probability concepts here. I don't care about the reducing fractions part right now. Okay, but if we had a calculator, you'd get decimals, then you wouldn't have to worry about reducing fraction, right? So don't even worry about that. Just leave them as fractions. It'll be a lot easier. All right, next one. Find the probability that the highest level of education completed by a randomly chosen person. Doesn't that sound like it could have been anybody? As soon as they use the word person or people, it's probably the 3172 number. Is the key that is saying here's what they are. They on the top. That is kind of telling you what's on top. Bachelor's degrees goes on top. So can I choose from anybody? Yeah, I got to use the whole chart, and I got to look for bachelor's degree. Where's bachelor's degree? Right there. So which of those 3 numbers should I use? Well, if I was only picking women or only picking men, I'd choose the first 2, but I'm using the total. So you should have said 1002 over 3172. Obviously, both even numbers are even, and you theoretically could reduce, but you don't have to. If you were using a calculator, you just divide them anyway. Okay. Next kind is where they start to get more tricky, because it's the bottom changes, and that's what I said is going to be the hardest, is to figure out what the bottom is. Randomly chosen woman. Now, I know this can be confusing, but that's not randomly picking from everybody. That's only picking from the women. So you narrow your chart down to just this, and you ignore the whole rest of your chart for this problem. Has earned a bachelor's or graduate. Bachelor's or graduate. Ooh, or. Do you remember, is that a bigger answer or smaller answer? Bigger. So therefore, we find the bachelor's or, means add to the bachelor's degree, bachelor's or graduate. Those 2 out of the total possible. So that's going to be 800, about 900 and something out of 1602. Okay, I think you're getting the idea here. The one other thing that will confuse people sometimes in this homework is when we get a little further down, it's going to ask you to do this chart. And people get all twisted up on this chart. It's so easy that they overthink it. The blue dies 1 through 6. The red dies 1 through 6. What do you get right here if you're supposed to put the sum? It's that easy. What is it? 2. What's supposed to go here? 3. And you just keep doing that for the whole chart. I know that seems too easy, and then that's why I seriously get like 45 questions about this. because they're like, that's guy, it can't be that easy. It is that easy. So what are we doing? We're finding out all the possible things that can happen when you roll 2 dice. See, most people think, oh, only all that can happen is you can get the numbers 1 through 12. So 12 things can happen. But that's wrong. Another key for probability is choices. If you ever get choices, you multiply your choices. Do you get that there's 6 things that the blue die could be, and there's 6 things that the red die could be? Do you get that means there's 36 things that could happen? You multiply your choices. Let's say at McDonald's, they give you a choice of 6 different drinks and 4 different hamburgers. You multiply your choices. 6 times 4 is 24 combos. If you have choices, multiply them. So here's my summary of all the important stuff. Everybody shut your iPads for a second. I need to give you the final, here's what you should be taking out of this. Shut your iPad or your laptop or whatever. Okay? Shut. Put it down, because I can't tell if it's on or not. Thank you. All right. Here's the big few. The bottom is the thing you should do first, and that's all your choices, okay? The possible outcomes. If it says or, you say it. Add. If it says or, you add. If it says an answer that's and, that means your probability is going down. It doesn't necessarily mean you subtract, but you will have a small number on the top because not many people will have this and this and this. So and are small answers, or are big answers. Next thing, if you have choices, what do you do with choices? Multiply choices. So if you in the morning look in your closet and you have 6 shirts and 5 pairs of pants, you can multiply the choices and you know the total combo, all the possible outcomes are 30. There's 30 different things you could have worn then. Combos, 30 combos. How many shirts? How many pants? You'll multiply them. Multiply choices. Or's are big answers. Ands are small answers. Always do the bottom first. And one last thing, if they say it's out of all the people, you obviously take the biggest number, the total. But if they say it's given that it's got to be a guy, that changes your denominator, and that's why you should always start with that. So if they say given it's got to be a guy, or we're only choosing from women here, then you narrow down your choices, and that means your total possibles are smaller. So if it's given, you change your denominator. Okay, I know not all of those things are making total sense to you, but by 2 or 3 days from now, you'll see how all of those things I told you are really important. Okay, open your iPad back up again and get into the homework for today. I am assigning all of them, but they're all really quick, and since I'm not making you do the calculator part of it, that saves you a bunch of time. So, all right, and that's all I have for the lesson for today.